Hello and welcome to today's Industry Solutions webinar. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator here at 12D Solutions. Our Industry Solutions webinars are designed to provide insights into overcoming challenges in an evolving industry in more effective and efficient ways. We'll keep running these webinars regularly and recording them for posting on our YouTube channel with links through our website. Our first 39 webinars from this Industry Solutions series, as well as the 44 webinars from our training series, are available online if you missed those. During today's presentation, you'll be able to type your questions along the way, as shown on the screen. We'll answer as many as possible of those throughout the webinar, and at the end, I'll read out some of your questions to the presenter if there's time. Today's webinar, 12D Model Modules, a brief overview, will be presented by Matt Stevens, who heads up 12D Victoria, taking care of 12D sales, support and training throughout Victoria and Tasmania. In this webinar, we'll discuss the various configurations a user can have within 12D model software. Matt will take you through the available modules and what they can do for you. Over to you, Matt.
First off, we'll take a look at the 12D model base. This is the heart of 12D. Every 12D model package must have 12D model base. The base module comes in 5 sizes. The smallest base size we sell is 50,000 points. We also sell 100,000 and 250,000 point bases. 5 million point base is probably the most popular and can be run happily through 32-bit or 64-bit Windows. Bigfoot, which requires 64-bit Windows, is only limited by your hardware. There are 3 main types of views in 12D model base. There is the plan view, the section view and the perspective view, any number of which can be created by the user for examining, constructing and editing information. All views are automatically linked so that the data can be viewed and manipulated using more than one view. Within the 12D model base, import formats such as CSV, 2D PDF, XYZ and other formats are supported. If you look at the diagram to the right, you'll see highlighted in yellow those formats. We also export non-proprietary formats such as 3D PDF, KML for Google Earth and IFC and STL for 3D printers. Basic string design is included. A super alignment that runs IP method is included in the base. Within the 12D model base, you get access to superstrings. The superstring provides a simple tool for 3D modeling of utilities such as telephone lines, electricity cables, gas lines and water pipes. Superstrings have the ability to have unlimited attributes stored on each string, vertex or segment of the string. This provides the ability to store, display and collaborate metadata information from the project to compatible information systems, providing the ideal basis for BIM information and as designed, as constructed information management. Here is an example of superstrings used to model services. The 12D model base comes complete with surface modelling, or TINs. A TIN is an acronym for Triangulated Irregular Network, and this is where triangles are used to model a surface. 12D has one of the fastest triangulation engines in the world. The base is respected by users due to its ability to create large and stable surfaces rapidly. Super TINs are also available for the creation of composite surfaces. The base module allows the user to input, create, view and output trimeshes. Trimeshes are similar to TINs but can wrap around on themselves to form solids. This makes 12D model an ideal product to handle your civil BIM. The 12D model base includes BIM. We offer a published interchange format, 12DA or 12D XML for all of 12D's data. The International Open BIM Exchange Format, or IFCs, almost all data in 12D model writes to this format, including superstrings, tins, drainage and sewer, networks and tri-meshes. These can be written out for seamless data transfer between other BIM packages, including attributes and metadata as the user-defined property sets. Conversely, 12D model can read in IFC files from architectural and other IFC supporting packages such as ArchiCAD, Revit, Tekla and Vectorworks. As part of this process, we can do clash detection, set out for construction and conformance checks. The 12D model base includes CAD in 12D. 12D model provides all the tools necessary for users to create, annotate, format and produce high-quality finished plans within a single software solution. Complete CAD tools are available such as lines, arcs, hatching, text placement, line styles, colour, weight control and symbols. Historically, manual CAD functions are being replaced with automated functions. Dynamic associated CAD objects such as dimensions, leader information, tables, information such as distances, object names and coordinates are associated with strings and can be automatically recalculated as the objects changed. Plotting and documentation is included within the 12D model base. We have plan, cross-section and long section plotting, and plot parameters allow plots to be produced including title blocks, true type fonts, line styles and symbols. As part of the 12D model base, you also get access to sharing. Multiple designers can be working on a project in different areas or sections, and these can be shared into a project and are not editable. The reverse can also occur when your users can share out their aspect of the model. This sharing capability is advantageous for designers working on multiple sections of the same project type, i.e. large highway, or alternatively across different functions of the same project. Survey, earthworks, volumes, road design and drainage, etc. The 12D model has the power of synchronizing sharing capability. This is when an update on the network notifies other designers and functions, or 12D users, that changes have been made. This can occur through a manual or an automatic sync, depending on your preferred settings. Other items included in your 12D base are the ability to create and read ADAC files, point clouds for licenses that are on maintenance, SUI, or the classification of subsurface utility information, or clash detection. The 12D survey module allows direct upload and download to all major surveying instruments, GPS and TPS. They include Leica, Topcon, Trimble, Zakia, Javad, Magellan, Spectra and Nikon. With the 12D survey module, users are able to reduce survey data, apply adjustments and transformations, create and label subdivision or estate lots, create Travis spreadsheets, create and upload set-out data. The survey module also allows users to manage, manipulate and move survey data to position within local and global systems. You can handle complex networks and adjustments using 12D Model's Travis editor. Adjustment method options include transit, Bowditch, Crandall, compass or least squares. You can utilise solar and star reductions without requiring almanac details. With the 12D survey module, you can use it for detail pickup, for 3D data, photos and attributes. You can use it for utilities pickup, all the 3D services. You can use map files to produce pipes, culverts, colours and fills. Attributes are supported. Field codes, we can utilise existing codes. It does support tinability. Also, you can use photogrammetry and LiDAR data with 12D survey. The 12D field module is next. This module provides direct control of motorised total station theodolites and direct feed of GNSS position data live on the screen using daylight readable PC tablet technology. The 12D field option runs on a ruggedized tablet and gives the user access to the full 12D model functionality, allowing you to take the entire project out into the field with the most comprehensive pickup and set out tools. With the 12D field module, raw survey data from an instrument is downloaded via a serial cable or PC card and converted to 12D model's field file ready for reduction. Measurements can be checked, edited and adjustments applied to field data. 12D's mapping file automatically sets string and point properties. Based on the fielding code, the mapping file, 12D survey, strings, points apply attributes, line styles, symbols, colours, solid fills, line weight and text labelling to all surveyed features. Data can also be separated into different models or layers. Field templating is also supported in 12D field, allowing a dramatic increase in field productivity. 12D model's field file provides an audit trail for quality assurance. The 12D field module keeps track of all the raw data that is captured by the survey instrument, and this can be downloaded at any point in time. This is especially useful to either comply with or exceed regulatory standards relating to data auditing. 12D model keeps track of SDR edits and formats for users so that authorities have a complete record of where the data came from. 12D field includes two key features, both set out and pickup. There is also an extra module for those working on tunnels that links through to 12D field. .12D field has been developed to enable surveyors and engineers to use both GNSS and total stations with the same software that is used in the office to design and finalise projects. 12D field setout has been developed to enable surveyors and engineers to set out using both GPS and TPS instruments for construction projects. Here are some set out options. Here too are some pickup options available to you using 12D field. Finally, to round out the survey modules that are available to you in 12D, we have the 12D eSurvey and ePlan modules. The eSurvey XML interface module allows users to read in and export out lints, basically for New Zealand. Land online, XML files, as well as. The ePlan module is for the electronic submission of cadastral information changes in eastern states of Australia and is currently under development. Now we can look at the volumes and detailed design modules. The detailed alignment design module adds another dimension to 12D model, providing the tools to carry out a full range of civil design work from land development to multi-lane highways with major intersections and exits. The parametric geometry generator, or components, quickly produces fully linked objects for intersections, turning lanes, roundabouts and other complex civil engineering objects. The detailed alignment design module allows template modifiers and string modifier operations which allow for an interactive design of the most complex civil situations. The modifiers include modifying the crossfall width and height between smart changes, projecting the crossfall between two existing strings onto a design cross-sections and strings, widening out two existing strings, creating cross-sections at specific user changes, and modifying the height or offset of the hinge string. The ability to create 12D model TriMos objects means that the creation and modelling of complex civil engineering shapes and solids such as tunnels, barriers, bridge components, subsurface construction layers and many more can be carried out easily and associated with other design elements. The alignment design is fully interactive and changes made in the design will be automatically reflected in other segments of your project, including design strings, cross-sections, triangulations, long and cross-section plots and visualizations. The Detailed Alignment Design module means designs created using superalignment element method enable the designer to link common properties of the design. For example, an at-grade intersection to a main alignment. Should any portion of the main alignment change in horizontal or vertical geometry, the linked or reference string can be resolved and the subsequent recalculations automatically applied to the design. Superalignment utilizes not only alignment designed by fixed and free method, but introduces a complete new approach to horizontal and vertical road design. Particular attention has been paid to the editor's graphics, highlighting of IPs and elements, tangent points, and chainage direction. The combination of the visualization module, rendering of the design, is also linked to the design geometry. Visualization of the design, for example, guardrail extrusion, is immediately updated as the design is amended. 12D model volumes and tin analysis. This module, there are two parts to the volumetric module, volume calculations and tin analysis. Calculations of earthworks volumes within a user-defined polygon, either by end area or exact calculations. Volumes can be calculated between a triangulated model and a fixed height, or between two triangulated models. Included in the volumes is an auto multiple stockpiling routine with simplified field coding that the multiple stockpile tins are created and reported. Reports of cut and fill areas and volumes are given on a section-by-section basis using the end area method, a height range basis by the cell method, or on a depth range basis using exact volumes. Depth volumes can be color-coded for validation and plots. The triangulation analysis has options to calculate surface area, depth contours, isopachs, and the intersection of triangulations, and options for slope, aspect, viewshed analysis. Color coding can be used for the slope and aspect analysis. Land use studies, landscaping and other civil design tasks can benefit from this comprehensive suite of triangulation analysis options. The 12D model pipeline. This module is activated for installs with the alignment module presently, whilst the license is on maintenance. This module is used to support the design of major pipelines of any diameter, i.e. 2000 millimeters, and any length. This module is also used to aid the design and layout of non-gravity long-run pressure pipelines such as pressure sewer pipelines. The pipeline itself shares similar properties to an alignment string, where the horizontal and vertical geometry of the pipeline are independent. These days, most people tend to use the superalignment, as the superalignment now can have a diameter or a width and a height. Finally, in the 12D volumes and detailed design, we have 12D model track. Track is activated for installs with alignment and volumetric, while on maintenance presently. The track module is an extension to the alignment and volumetrics and tin analysis modules. This module has a few extra functions to complete track and rail design. In the new version, the super alignments have new rail, spiral types, chainage equalities, compound elements, duplicated elements, double tracking. Some of these features are the track centerline calculator, the centerline point numbering, low rail DTM, equalities, K-posts, internal equalities and zones. We do the slew calculations, slew diagrams, and export to Excel. You can have the turnout creation and the placement, and also cant calculations done with inside 12D model. .12D model offers a comprehensive input-output options for the transfer of data with third-party packages. The ArcView module will read ArcView shape, SL, SHX and DBF files into 12D model. The mapping of any attributes found in the ArcView file can be specified by the user. Because the ArcView shape format has no string name, color, model or layer information, this data can be passed as attributes when writing data from 12D model to ArcView files. LandXML input-output. LandXML is a developing standard for transferring some geometric data between software packages. 12D model endeavours to support this evolving standard. MapInfo MIF tab input-output. The MapInfo module reads MapInfo MIF, mid or tab files into 12D model. The mapping of attributes in these files is under the user control. With MapInfo and ArcView, the attribute manipulator enables us to put the data where we need it, so these two particular programs can read the data through their attributes. The 12D model GIS. This module provides an interface between 12D model and other spatial information systems such as GIS and web mapping utilities through the use of open source FDO, which is featured data object technology. We can link up with ArcSDE, ArcGIS and ArcGIS Server, MySQL, OGR, Oracle, SQL, Web Mapping Service, Web Feature Service, and the data from within 12D model can be directly added to the connected spatial information server or database, removing the need for output files to be created to share some data. Next we'll look at the 12D visualization module. The visualization module uses Windows OpenGL to quickly produce realistic perspective scenes of your design. Surfaces can be shaded, photos draped onto the terrain, textures applied to triangles, and shapes extruded along strings. A rendered perspective view or drive-through provides a realistic three-dimensional image, which is often the easiest way to convey a design to people who find engineering plans and contours difficult to interpret. A library of objects such as trees, lights, guardrails, fences and walls is supplied with 12D model so that new users can immediately produce results. New objects can be created using faces and extrusions to cover almost all situations. Routines to create road line markings, signs and billboards complete the overall effect. Timelines add moving cars and other objects to create realistic scenes. Drive down roads and flyovers can be written to video files for replaying and use in presentations. The visualization module in 12D is also used to show the results of a two-flow analysis or a 2D drainage analysis, making it very easy to see through a timeline the results of the analysis. Next we look at the 12D model input-output modules. 12D model offers a comprehensive input-output options for the transfer of data within third-party packages. The DWG DXF input-output recognises almost all AutoCAD entities, including blocks, and makes the appropriate interpretation in terms of the 12D model elements. The DWG DXF output module writes out plots, three-dimensional data, and triangles in DWG DXF format. The Genio input-output module is used to read and write MOS Genio data files. The Genio reader recognises the two default Genio input formats, version 6 and 7, and the Genio options 001 and 003 used for format variations. MOS-free format using commas and the field number equals syntax is allowed. 2D, 3D, 4D, 6D and G strings are recognised with names preserved as well as triangulations. Genio models can be read directly into 12D models, or Genio data can be mapped with user-defined models, colours, break lines and line styles. The MicroStation DGN input-output. The MicroStation input-output module is used to read specific information from the MicroStation DGN file and to write out plots, three-dimensional data and triangles directly to MicroStation DGN files. Geocomp input. The Geocomp input reader reads and interprets the data contained in the Geocomp points and strings files. 12D model macros are also provided to read in Geocomp lot files. CivilCAD input. The CivilCAD input reads and interprets the data contained in the CivilCAD ASCII file format. Both version 4 and version 5 CivilCAD ASCII files are supported. SDR Map and Design. The SDR Map and Design reader allows existing SDR Map and Design users to import their existing data into 12D model. The Rivers interface modules offer river engineers and mappers new levels of flexibility, power and productivity. 12D model substantially reduces modelling setup time for river, floodplain and open channel studies. Start with survey data, airborne laser scanning, LiDAR, cross-sectional data, DEM data, CAD data, or a combination of these to create a ground surface for your river. Include buildings, roads and channel improvements in design. 12D model efficiently handles many millions of points. For additional clarity, aerial photography can be used as backdrops for your work. The user specifies the river centerline, overbanks and cross-section, straight line or bent locations. 12D model automatically determines river levees and exports the 3D river system to programs such as HECRAS, Mike11, UNet, ISIS and XP Swim. ISIS and XP Swim storage reservoirs receive stage area curves directly from the surface tin. The water levels are read from the output files and users can create their own flood level files to map the observed floods. Calculated flood limits can be shown in the plan, section or perspective views. Flood inundation maps with depth contours and colouring by depth ranges can quickly and easily be prepared. The utilities and services area of 12D model has quite a few modules. The drainage string module, or the drainage module, allows the design and management of horizontal and vertical drainage networks, typically those required for new land subdivisions and development projects. Existing drainage networks can be reproduced easily for analysis or realignment designs. The drainage string itself consists of pits and manholes joined by straight or curved pipes. Invert levels and pipe grades can be automatically adjusted, set and modified either graphically or by typed input. Manhole and pit pipe type libraries are able to be customized to suit local authorities or manufacturers. For either large or small networks, 12D can control pit naming, pipe and manhole alignments, plan creation and long section production. These drainage networks can be imported to spreadsheet or to other design packages such as Drains, PC Drain, XP Swim, RAT 2000, RAT GL, ILSAX, Windows, which is micro drainage, and spreadsheets. Some of these are separate modules. Clashes with other drainage networks or services are managed for the network, with clashes reported and modifications suggested in problem areas. The network can be reported for pit schedules, pipe schedules, and excavated quantities can be tallied. Drainage design can be simple or complex as the project dictates. The 12D model drainage analysis module allows for the hydrological and hydraulic analysis of a drainage network. Site-specific rainfall data can be entered and stored in a rainfall file that can be utilised across many projects. Using the rational method, catchments with variable runoff characteristics can be created and maintained, with the time of concentration calculated by typed input or automatically determined by graphical flow path creation. Multiple catchments can be assigned to pits or manholes in a drainage network. The hydraulic requirements of the drainage network are automatically calculated based on the rainfall intensities and return periods from the rainfall file. Pipes within the network are then sized and managed in the network editor, with overland and bypass flows able to be calculated and graphically represented. Losses within pits and flow velocities are determined with the hydraulic grade lines shown and plotted. The network can be designed and sized based on flow depth or pressurized freeboard methods, and hydrological and hydraulic reports automatically produced. Dynamic drainage. The dynamic drainage module allows hydrological and hydraulic modelling based on volumetric or hydrograph methods, and hydraulics based on the Savannah equation. Complex hydraulic situations, including adverse grades, flow reversals, tidal outfall, flap gates, and fixed backwater, can be modelled within the network due to the introduction of dynamic wave calculations. Many types of conduit configurations can be included in the drainage network, such as rectangular and trapezoidal conduits, as well as weir and orifice calculations. The inclusion of the hydrograph methodology allows for the design of basins such as dry retarding, wet detention, and interconnected basins to be properly supported. Hydrograph methods already implemented within the software are ILSAX, SWIM, and SCS. Hydrological components of such as snowmelt, groundwater, exfiltration can also be modelled. Reporting and the analysis of the dynamic network can be complemented with a range of time series graphs navigated from within 12D that can be saved and exported to other documents. These graphs include depth, elevation, volumes, inflows and outflows. For our Australian customers, Australian Rainfall and Runoff 2016 has been released and has some major changes in water analysis using the dynamic drainage analysis. These changes include, but are not limited to, updates in terminology, hazard criteria, new IFD data sources and formats, along with new temporal pattern management. 12D Solutions is currently working through all the changes required to fully support AR&R 2016 within 12D model. The 12D model sewer module is an extension of the drainage module and supports the design of gravity-operated wastewater reticulation systems, typically those required for new land subdivisions and development projects. When satisfied, the design invert levels connections from the design line to the existing house blocks can be added and reported on. Special wastewater reticulation long section plots show the existing surface, manholes, design pipes, pipe grades, property connection points, and all obstructions. We also have a dynamic water supply module. This performs hydraulic analysis and models the water behaviour in pressurised pipe networks consisting of pipes, junctions, pumps, valves, storage tanks and reservoirs. This module uses the EPA net engine. The next area of 12D modules we'll look at will be the 12D two-flow drainage modules. The 2D drainage open module is two-flow unlimited cells requiring the 5 million point 12D model point base or larger. The 12D drainage 2D open module also requires the 12D model base, drainage analysis, dynamic drainage visualization and two-flow interface modules to run. The 12D 2D open module combines with the functionality of road flow, two-flow interface, and also includes unlimited cell two-flow license. This module is ideal for users who want to run 2D model analysis on an unlimited cell area and also have the ability to have control over all aspects of the model as is available within the two-flow TCF file commands such as edit files, update GIS files, XF4, XF6 grids, launch two-flow, read results, view the check files are all controlled from one panel. All features and TCF file commands are available for application in the model. We also have a 2D drainage 100,000 cell version. It's exactly the same as the open version except you are limited to 100,000 cells. 12D model road flow requires a 12D model base and visualization modules to run and drainage analysis, dynamic drainage to model the drainage network. The 2D road flow module allows rapid setup of a 2D model based on rain and grid analysis mode. To run the model, the user simply needs a surface DIN, a model extent defined by a polygon, initial rainfall intensity information, and a surface material N values to establish a 2D overland flood model to be initialized and then run. This module is invaluable to the non-2D modeler, such as a road designer, to be able to run simple but comprehensive runoff analysis models on selected areas of their design. Results such as depth of flow on the design surface, aquaplaning analysis for example, and width or extent of surface flows on the design surface for allowable encroachment on vehicle lanes can be viewed and then interrogated. The road flow analysis creates a two-flow control TCF file that can, with the purchase of the two-flow interface module, can be opened, amended and run in the two-flow interface by experienced two-flow modelers. The 12D model two-flow interface module also requires the 12D model base and the visualization modules and a two-flow license to run. The interface provides users with the complete command and structure control to compile the TCF file. The interface also allows an existing TCF file created via typed input to be read and run within 12D model. with the results viewed and interrogated also in 12D model. Results can be viewed in plan or perspective as a grid tin containing interchangeable tin values. Results over time can be viewed in a visualization timeline. The final module is the 1D 2-flow interface. This module links a 1D flow to an existing WBM dongle that runs 2-flow.
Thanks for that, Matt. I think that was a pretty comprehensive overview, so I haven't seen too many questions coming through. If anyone has anything they really would like to ask out of that, then feel free, or otherwise we'll email you answers to your questions later on. And as I'm sure most of you know, our 12D Technical Forum is on in Brisbane this July. We'll be showcasing all of the new features in 12D Model 14 and 12D Synergy 4 and much more. So I think you may have seen, if you caught Lee Gregory's presentation recently, that there'll be a technical preview version of 12D Model 14. So if you're keen to put any of these other modules or anything you've seen today into action, then it's definitely a good opportunity to come along. Our next two Industry Solutions webinars will be 12D Technical Forum Preview on the 6th of June, and then a replay of our immensely popular ARR 2016 and 12D webinar on the 13th of June. So that'll go into a lot more detail of some of the stuff that Matt was talking about today. So register for those now if you haven't already, and keep an eye on our emails and social media channels for more great upcoming topics in this and our training series. We'll pop the recording of this webinar up on our YouTube channel, 12D Model, in the next couple of days. And if you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.